Hello everyone. In this video we are going to study basic understanding of probability, and then we will talk about the mutually exclusive events, which is the second part of the understanding probability. Basic rules for the computing probability is we have something called the classical approach. Is that assume that given procedure has n different simple events, and then that each of those simple events has an equal chance of occurring. So if the event A of those simple events has equal chance of occurring, okay, and if the A can occur in S of these n ways, then that A can occur is going to be simply number of ways A can occur, then divided by number of total events. Okay, so you can understand this one by looking at the example. So let me give you a simple example here. I have 52 deck of cards here. Okay, so we have 4 different suites here. Then one through Jack, Queen, and King. One is not a ace, just a regular number 1. So, what if we want to find what is the probability of, if you pick one card from the 52 deck of cards, what is the probability of you getting that heart? So we want to write it this way. So what is the probability of getting? The P means the probability, and the getting heart. Okay, so if you go back up here, and the rule says, okay, how many ways that you can have the heart? Well, you can have 1 or 2, 3, 4, 5, 6, 7, or 8, 9, 10, 11, Jack, Queen, and King, right? So there are 13 different ways you can pick a heart. Well, there are a total of 52 cards that you can pick from, right? So that's the bottom one there. So there are a total of 52 boxes here. And then you have checked the 13 boxes so that each one has a equal chance, right? So that gives us the 1/4. So it's about 25% probability that if I just pick any random card from the deck and it will give you the heart, is about 25%. Okay, so that's how the simple probability works. Now the thing here is that we got something like this. I'm just going to put okay, I'm going to make this one so you guys can see. So this time I am going to select Jack also, okay, like so. So then I'm going to rewrite the questions. Okay, now what is the probability of getting heart or Jack? Now this is not simple anymore, right? Because the problem here is that we have or in between. Okay? Now that or means that it can be either one. It can have a heart or the Jack. Okay? So whenever we have the 2 events are connected with or, we have to determine if the 2 events are mutually exclusive. Determine if these 2 events are mutually exclusive. What it means by they are mutually exclusive simply means this. you have outcome of each event here. Okay, so we have, I'm just going to write a heart event. So we have a heart event over here. Then we have the jack event. Right? Now, you are looking at the outcome of these two events. If there are same outcome, in this case, in this problem, if you have the same face or same numbers, that means that it is not mutually exclusive. So mutually exclusive simply means that you cannot have the same outcome from these two events. That's what the mutually exclusive means, right? They have to be a different outcome. All right? So if you look at the hard side, you can have what? 1, 2, 3, 4, 5, 6, 7. You can also have jack. Jack of queen, right? You got 1, 2, all the way to the jack, queen, and the king. Now for the jack, you can have what? Jack of club. Okay, you can have a jack of spades. You can have a jack of heart. You can have a jack of diamond. Now the problem here is this. This is also jack of heart, right? And also this is also jack of heart here. Okay? So that means that we have same outcome. So these two are not mutually exclusive. Okay? So if two events are mutually exclusive, okay, now if, I'm just going to write this, if two events are mutually exclusive, okay, then you have to write it like this. The probability of, okay, I should say event A. I'm just going to erase this. Okay. So let's say we got two events, A and B, just like the heart and jack. A or B. Then all you have to do is you're going to have to add the probability of both events. So probability of A plus the probability of B. Okay, that's how you're going to find the probability if A or B. Now if two events are not mutually exclusive, if not, then your formula becomes a little bit different. Okay, even the same thing. Okay, so now it becomes the probability of A plus the probability of B. Now then you're going to have to subtract the common overlapping area, which are called the P, A, and B. Okay, so this is going to be overlapping area. Okay, so you have to be careful whenever your problem is connected with the OR. Okay, that means you're going to have to determine whether these two events are mutually exclusive or not. If they are, okay, you just add those two probability. If they are not, then add those two probabilities and subtract the overlapping area. Okay, so let's just go back to this example here. We want to find the probability of either picking a heart or jack. It doesn't matter which jack it is. Okay, so when you look at these two events outcome, the outcome of the heart and outcome of the jack, we have the common outcome on both events. We can have a jack of a queen here on the left hand side with the heart, and we can also have a jack of a queen of the jack. So these two are not mutually exclusive. Okay, so what we have to do now is that we're going to have to find the probability of a heart, okay, plus probability of a jack. Then we're going to have to subtract jack of heart. Okay? So let's find the probability here. So we also know that the probability of a heart is going to be what? We just found that out. There are 13 heart cards out of 52. So there will be 13 out of 52. And the jack, there are 4 different jacks over here. So there will be 4 out of 52. Okay? Now the overlapping area is right here. This is overlapping area here, right? So that means we're going to have, there will be 1 box out of 52. Okay? So that will be 13 plus 4, which is a 17, and 17 minus 1, you get 16. 16 out of 52. So let's find out what the decimal is for this one. Then we'll find out what the probability is. Okay? So that will be 16 divided by 52. That will be about 0.307. So it's around 31%. Okay, so there are 31% probability that you can either pick heart card or the jack card. Okay, so we call this, mutually exclusive problems here. Okay, so let's keep in mind that the one important thing when you have the mutually exclusive events, you need to recognize that whether these 2 events are mutually exclusive or not. So first thing you have to do is that make sure that these 2 events are connected with OR. Okay, so if that's the true, then you have to look at the outcome, see if there is any overlap, or if you have the same outcome from these 2 events. If you don't have the overlap, or if you don't have the same outcome, then your two events are mutually exclusive, so you just add those 2 events probability. If 2 events are not mutually exclusive, meaning that some outcome is the same, or there is overlap, then you're going to have to add those 2 probabilities from each event. Then you're going to have to subtract the overlapping common area. Okay? Now the math is not a big deal, just adding and subtracting, but understanding whether you have a mutually exclusive or you don't have a mutually exclusive, it does make a difference. Okay? So make sure that before even you punch in numbers in, determine whether you have the mutually exclusive events or not. Okay? Then once you determine that, then you just plug in the probability of each event. Okay? So that would be our one thing that everyone needs to understand that. Okay? Because oftentimes that students just automatically think that they just putting numbers in there without thinking whether these 2 events are mutually exclusive or not, and then then it's going to be a incorrect way of finding the probability. Okay, so whenever you have questions asking either this event or that event, you must determine whether these 2 events are mutually exclusive or not. Okay. So just make sure that you understand the example that I gave you, okay, and try to understand what the mutually exclusive events are, because the probability at the outcome is going to be different, okay, for the mutually exclusive events and not mutually exclusive events. Okay, all right. Thanks. I'll see you in the next video.